Hi there! Ever struggled with adding heatset inserts to your 3D prints? Or try to avoid printing models that need them? In today's video, I will show you how to DIY this stealth press with a step-by-step guide and useful commentary. I'll also cover how I printed its parts on my Sovol SVO8 and the surprise new GDQ1 Pro from geekbuying.com, and share the best sources for the non-printed parts from AliExpress. Every serious 3D printing enthusiast needs this tool for adding heatset inserts into 3D printed parts. Here you can see how I used my newly built stealth press to upgrade my SVO6 Plus clipper screen with a new front part. The back of my redesigned case has the cooling fan, of course, so important to keep it cool in this time of the year, with the speed controls as explained in these two earlier videos for the SVO7 and clipperized SVO6. Now I reprinted the front with the upgraded graphics, and for fastening, these heatset inserts are so much stronger and easier to add than the super glued hex nuts I used in my original videos. The Stealth Press is an open source project available on Printables. It includes easy to source standard components like the linear rail, a generic soldering iron, and an ingenious pulley mechanism using a keyback or door puller. This can be built in less than an hour for under $40 in materials, but before I did, I couldn't find a good, concise video with useful commentary to prepare me for the process. So here I am making one. This is Gergo, and you're watching Gergo Print 3D, the YouTube channel about my 3D printing adventures and DIY projects. You will find many more fun and practical printing projects, techniques, reviews, and printer tuning tutorials in my ever-growing library of content. All my videos come with accurate subtitles that translate well into other languages. Use YouTube's speed controls to further improve the experience. So, according to their documentation on Printables, we will need the following components: a soldering iron with replacement adapter and tips for heating various size inserts. It needs to have temperature controls because each filament type needs different settings. The higher the wattage, the quicker it heats. This 80 watt is quick enough. Make sure to get the correct plug for your region. Next, a keyback, or in my case, a door puller that will pull the soldering iron up. A 300mm linear rail with carriage, and a set of smaller components, namely 40 or so M3 heat inserts, 4 washers, M3x25 screws to fasten the door puller, lots of M3x8 screws for the rest of the assembly, a pair of larger M5x25 bolts for the bearings, either 2 pairs of stacked ones or just 1 pair of idlers in my case, and a large washer to be used as the center spacer. All these are standard components that you could get individually, but my recommendation is to buy them as a kit from AliExpress. These kits run for less than $40, including the soldering iron, and they are guaranteed to be compatible with the 3D printed designs I used. I will put the link in the description below. Even if you already have a soldering iron, I recommend getting one with the kit because it will be permanently mounted. As for the designs, I downloaded the starter set from Printables.com and printed everything out of this yellow ABS on my enclosed Sovol SVO8. For strength, they recommend using 4 walls and 25% infill, which I prefer to be 3D honeycomb. You will find ABS filament presets for Orca Slicer in the wiki on Sovol's website. But be sure to watch my last two videos on how to tune the generic profile to your brand of filament and what macro modifications are needed on the Sovol SVO8 to correctly print with filaments requiring temperatures other than 65 degrees Celsius. With these preparations, the printed parts came out great, with only a tiny bit of warping on the biggest piece, which could have been avoided by using a brim, or maybe if I printed this too in my new Qidi Q1 Pro with its fully sealed heated chamber. This new printer arrived early. I just unboxed it yesterday. I'm going to use it for a few weeks before I post a comprehensive comparison with my Sovol printers. My first impressions are good though. I'm sure it will be interesting for many of you to watch a duel between the top two feature-rich budget Core XY printers. Be sure to subscribe not to miss this and lots more content on all my printers. As you can see, I'm reprinting the soldering iron mounting piece in the Qidi. They include multiple variants of this part, and it turns out ID16 fits best for the iron I received. The mount for the puller was even trickier. The AliExpress seller offers to send you all the STLs if you message them your email address, but I found a better design by Thomas F. Jen for the door puller on printables that did not require support. However, the 18mm thick door puller included in my kit needed a remixed cover by Zero Flow. I will put the links to all of these in the description below. I printed these also on the Q1 Pro. Using a rudimentary ABS preset I cobbled together, I must say the heated chamber is a joy for printing ABS. It heats up in a few minutes compared to the 40 minutes of heat soaking required by the SVO8. For larger parts, you need the SVO8's volume, but it takes its time to prepare. We'll start by assembling the iron, as this build requires a lot of heat inserts. It's a chicken and egg type of problem, but if we complete this project successfully, these will be the last ones we need to do manually. Attach the M3 tip, as that's the one we'll be using. I've set the temperature to 320 degrees, which I've read should be 20-40 degrees higher than the print temperature of the filament for the part. For Sovol's ABS preset, the printing temperature was 280 Celsius. By the way, if you're finding this guide helpful so far, please give this video a thumbs up and leave a comment below with any questions you might have. I'm following the written assembly guide they provide in the Stealth Press project on printables. They have us start by putting 7 heat inserts into the leg part. The smoother edge should face the hole. Without a Stealth Press, it takes a bit of effort to push them in perpendicularly in one continuous motion until they go just a tiny bit under the surface. I use this hammerhead to flatten them while cooling them down. The 7th insert goes in the back. To keep it straight, I place the part on the edge of my table. We continue by putting 11 heat inserts in the center axis. I recommend using tweezers to handle the tiny heat inserts. The written guide is not the clearest on this. 6 go on the front, 2 on each side, and 1 in the back. Next, the top piece needs 6 inserts. I use this piece of plastic to support the part to keep it straight. By the way, this is a piece of rail they've included in case we need to service the carriage on the linear rail. At this point, the manual tells us to add the washers and bearings, but I recommend doing all the heat inserts first while the iron is hot and coming back to this step later. So you can see I've moved on to the support arms. They each needed just a pair of heat inserts. The build plate receives 2 in the triangle-shaped guides. I had a hard time getting rid of the sacrificial support in the center of the build plate. The project includes a variant of this model without the included support. You might have an easier time if you let your slicer generate the supports. Now we are putting 2 heatset inserts into the door puller mount. You can see I've drilled an extra hole that the original STL was missing to hold the door puller in place. You see I'm adding a heat insert into one of these drilled holes. It's not going to hold too well, but it's kind of a convenience addition for the time of assembly. The reprinted ID16 iron mount and the arm that attaches to the top of the linear rail carriage each need 1 pair of heat inserts. At this point, we can unplug and put aside the soldering iron to let it cool while we assemble the parts. This is when we can go back to the step we skipped, adding the bearings to the top part. Sandwich them between the washers the AliExpress kit includes. I found it easier to push the stacks in when the slot is horizontal. Jiggle them with the M5x25 bolts, and these bolts simply drive into the plastic. Again, not the strongest hold, but they will only need to withstand some perpendicular tearing forces. We connect the 3 parts of the axis, and it will be held together by the linear rail itself. A whopping 12 screws will hold it in place. Be very careful, however, not to pull the carriage off. In fact, they have us raise one of the bottom screws with a heat insert to stop the carriage from accidentally sliding off the rail during assembly. Fasten the support arms on the sides with the heat inserts closer to the top. Then we attach the left and right strain relief pieces, which I printed out of black PETG just for a little contrast. Screw the 2 halves of the puller mount together and secure it on the back of the device. Insert the door puller with the wire on the side of the mounting point, and then you can use one of the M3x25 screws to secure it in place. Their original design actually includes holes for 2 of these, so you will have a spare M3x25. Now the package came with a miniature Allen key for the grub screw on the knot. Loosen it and make the loop as small as you can. After tightening it, make sure that it holds well. Then loosen the other grub screw, pull the end of the wire over the bearings all the way down on the other side, and then retighten the second grub screw. This will make the next part of the assembly much easier. You will not need to keep pulling the wire. Now we attach the arm to the linear rail carriage. It will go over the wire. The wire needs to go in its center groove. You can see I drove one of the screws in loosely so I could pivot the arm to bring together every moving part. Then I added and fastened the rest of the screws. I ended up heating the knot with the iron to fit perfectly in its slot at the bottom, but this was for aesthetics only. It will work okay even if you don't do this. Now we attach the build plate to the leg. It was a bit tricky because of the slight warping, but I finally managed. The front 2 screws are so deep you will likely need to resort to using an Allen key for them. The electric screwdriver will not be able to access them. Secure the iron mount to the front of the arm with the arrow on it pointing down. Force the iron's cable through the slot and pull the ring all the way past the display and buttons on the soldering iron. With the 16mm mount variant, I had to remove the silicone sleeve from my iron to fit, while the 18mm variant was too loose even with the sleeve. We fasten the clamp around the iron with 2 more M3x8 screws. Make sure it holds well. The screen is supposed to face forward and the buttons need to be accessible, of course. After inserting the soldering iron's cable into the strain relief on the side of our choice, let's use some super glue to secure the large washer in the center of the build plate. I press it down with the hammerhead until the glue cures. It works amazingly well. This is an easy build. Order the parts from AliExpress and make one for yourself. All the necessary links are in the descriptions below. I keep testing my Sovo printers and the new Qidi Q1 Pro with different materials and projects. If you like something you see here, you can support my endeavors by using my affiliate links to printers, accessories, and materials all listed below. I keep combining laser cutting and 3D printing. You'll see more of these types of projects as well. To help you prepare your SVO8's start macros to print high-temp filaments like ABS, ASA, TPU or PETG, I suggest continuing with this video. Or if you have seen that, you can learn about filament tuning for any 3D printer in this video. All in all, be sure to go print 3D. I appreciate the time you spent watching another Gergo Print 3D video all the way to the end. Thank you.